Hello and welcome back to another video. In this one we'll discuss part 3 of the second order differential equations, the undetermined coefficient method. So in the previous videos we discussed the ways of finding the general solution for a second order non-homogeneous equation. We discussed that second order equation consists of a y double dash plus b y dash plus cy is equal to a function of x. Now, the general solution consists of two parts, yp and yc. Yp means particular solution and yc means complementary solution. The complementary solution depends on the value of the roots. So by obtaining the second order or second degree equation from the second ordered equation, we'll find the roots, and from the roots we can obtain the general solution for yc, and they are exactly the same as the non-homogeneous general solutions. So I suggest, if you haven't seen them, I have videos in the link down below. And the particular solution depends on the value of the f of x. So the function of x here depends, depending on the value, we have three different solutions. So in previous videos, in part 1, we took if the f of x is a value that is not exponential or a trigonometric function, therefore our particular solution would be ax squared plus bx plus c. And obviously we'll have to find the value of a, b and c. In part 2, we had if f of x is an exponential function, and therefore we took yp is equal to a multiplied by exponential cx. Now in this part we'll take the last possibility, which is if f of x is a trigonometric function, and then our particular solution would be c1 cosine nx plus c2 sine nx, and obviously that would be more clear in an example later. Keep in mind that c1 and c2 are constants, so they could be, instead of c1 and c2, could be a and b, like or a1 b1 or a1 a2, for example. They are just constants, so that, like they're not set to be just c1 and c2. And now we'll move on to an example. So now we have this example. We have y double dash plus 4y dash plus 3y is equal to 5 sine 2x. So our first step is to find the second degree equation. So we have r squared plus 4r plus 3 is equal to 0. We'll use the brackets method as it's easier than the quadratic formula. So we have r and r, positive and a positive, a number that multiplies to give us 3 and adds up together to give us 4 is 3 and 1. Therefore root 1 would equal negative 3 and root 2 is equal to negative 1. Therefore our complementary solution is c1 exponential negative 3x plus c2 exponential negative x, and that's our complementary solution. Now our particular solution yp would equal a cosine 2x plus b sine 2x. Now we have to find the values of a and b, and to do so we'll have to derive this equation yp twice. So we have y dash would equal to negative 2a sine 2x plus 2b cosine 2x. Y double dash is negative 4a sine 2x plus sorry, that would be minus 4b cosine 2x. And now we have to substitute that's sine sine 2x, miscalculation. Now we'll have to substitute the value of y double dash, y dash and yp into our equation. We'll do that as such. Negative 4 negative 4a sine 2x. I messed up again. That should be cosine. Sorry about that. Negative 4 cosine x minus 4b sine 2x plus 4 multiplied by negative 2a sine 2x plus 2b cosine 2x. Let me just move that a little. Plus 3 multiplied by a cosine 2x plus b sine 2x is equal to 5 sine 2x. Now we'll group all the sines together and all the cosines together. So we have negative 4b sine 2x. Let me fix that though. Minus 4 multiplied by negative 2 is negative 8a sine 2x. 3 multiplied by 1, so we have 3b, that would be plus 3b sine 2x, and obviously that would equal to 5 sine 2x. 5 sine 2x. Now if we divide by sine 2x, we are left with negative 4b minus 8a plus 3b is equal to 5. Now negative 4b plus 3b would be negative b minus 8a is equal to 5, and that's our first equation. And we have all the cosines together, so negative 4 cosine 2x, 4 multiplied by 2 is plus 8b cosine 2x, and 3 multiplied by 1 is plus 3a, that's a, 3a cosine 2x is equal to 0. Now we divide by cosine 2x and we're left with positive or negative a plus 8b is equal to 0, and that's our second formula or second equation. Now we can multiply the we'll use the elimination method, so we have negative b minus 8a plus equals 5 negative a plus 8b is equal to 0. Now we can multiply the top by 8, so we have negative 8b minus 64a and 40 I have 64a, sorry, and is equal to 40, and the 8b and b get cancelled together, so we have so we're left with negative 65a is equal to 40. So a is equal to negative 40 divided by 65, which is just 3 divided by if we divide by 5, we'll get 13 in the bottom, and negative 8 at the top. So so a is equal to negative 8 divided by 13. Now we can substitute the value of a into any of our equations here. Negative a plus 8b is equal to 0. Negative 8 divided by 13 is equal to plus 8b is equal to 0. Now the negative and negative get cancelled together, and we move 8 divided by 13 to the other side, so it becomes negative again. So we have b is equal to 8 divided by 13 multiplied by 1 over 8, and that would give us b is equal to negative 1 divided by 13. Now, since we have the value of a and b, we can substitute them back into our particular solution. So yp is equal to a is negative 8 divided by 13 multiplied by cosine 2x plus the a is negative sorry, the b is negative 1 over 13 sine 2x. Now we have our particular solution in its full form. Now all we have to do is group the two solutions together. So y is equal to yc plus yp, and that would equal to c1 exponential negative 3x plus c2 exponential negative 2x minus 8 divided by 13 cosine 2x negative 1 over 13 sine 2x, and that would be our final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful.